Chevron is involved in all aspects of energy production, and we're at the forefront of advances in safe and successful exploration and production, including natural gas from shale. As in all our operations, we are committed to safety, protecting people, the environment, and contributing to local communities. Chevron applies high standards and processes which always meet or exceed government regulations. We aim to be a good neighbour, partner, and steward of the environment. Natural gas from shale was formed in the same manner as all hydrocarbons. Over time, the remains of minute organisms were deposited in sediments at the bottom of ancient oceans. Through geological time, these sediments were buried and subjected to heat and pressure, turning the organic matter into oil and natural gas. In most oil and gas reservoirs, the hydrocarbons migrate from the source rock and are trapped in overlying porous rock. These reservoirs have been produced worldwide for over a century. Natural gas from shale is produced directly from the source rock. Since the shale is fine-grained and impermeable, the gas does not flow naturally. In today's changing world energy landscape, natural gas from shale offers economic benefits and security of supply. Advances in knowledge and technology in the oil and gas industry are now allowing companies to develop natural gas from shale. Once we have acquired a license from government, we develop an accurate picture of the subsurface through the acquisition of seismic data. Seismic surveying uses reflected sound waves to map geological layers deep underground. Seismic surveys are performed by a range of techniques. One of these is vibrosize, a method requiring a group of large trucks equipped with vibrating plates. Approximately every 25 meters, the plates are lowered onto the ground and vibrated to send seismic waves down into the earth. The trucks spend a few seconds vibrating at each location, and the energy released is similar to that from a pneumatic drill. Seismic operations are only conducted during the hours of daylight and at a minimum distance from nearby buildings or water wells. Well sites are selected based on geological understanding and distance to buildings, access by road, agreements with landowners, and availability of water. The selected sites are leased and permitted following consultation with local residents and authorities, after which an area of land is cleared, levelled, and made ready for the arrival of the drilling rig. A site access road is built as far from residential areas as possible to safeguard pedestrians and traffic. Chevron's exploration drill sites cover an area approximately the size of a football pitch. The rig will stand to a height of almost 40 meters. The minimum distance between homes and the rig will be 300 meters. At this distance, noise levels will be lower than traffic noise. Initial drilling operations are expected to take around 2 months. Water is required for drilling operations, and it will be sourced either from on-site wells or transported by tanker. Water access and disposal is subject to local and national regulations, and subject to our own strict water management standards. Sampling is carried out in neighbouring wells before and during all operations to ensure there is no impact on the water table. Fluid called drilling mud is used during drilling operations to maintain pressure, cool the drill bit, and bring the rock cuttings to the surface. The drill cuttings will be transported to a licensed waste disposal site, and traffic movements will be monitored and kept to a minimum. Vertical wells are drilled more than 2 kilometers deep to test for the presence of organic rich shale. Chevron has global standards and procedures and applies best practice to ensure we drill wells safely and without environmental harm. Well design will be reviewed by our own internal specialist and permitted by the relevant authorities. Protection of shallow aquifers, commonly 200 meters below surface, is critically important. Our wells are lined with multiple layers of steel casing and cement, which form a continuous barrier of protection between the wellbore and the aquifer. Pressure tested for strength, the casing lasts the life of the well. Samples of shale, called cores, are brought to the surface for analysis to determine whether natural gas is present and how the shale will respond to fracturing. If the results are promising, the next step would be to perform a small fracturing job to test the shale's potential to fracture and release its gas. If the results are negative, the well will be plugged with cement and the land will be restored to original use. If results from exploration wells are encouraging, hydraulic fracturing will take place. Hydraulic fracturing is the process of injecting water, sand and additives under pressure to crack the shale rock and allow the natural gas to flow. This technology has been used safely for 60 years in more than 1 million wells worldwide. It is not unique to shale. The fracturing additives are less than 0.5%, and these help to make the process more efficient, minimize friction, and carry the sand deep into the fracture network. All substances used are governed by local, national, and European regulations. If the results from fracturing and testing a vertical well are positive, we'll progress to drilling horizontal wells. The anticipated water usage for drilling one well and performing single-stage fracturing is 2,400 cubic meters. Multi-stage fracturing of a horizontal well is expected to use 16,000 cubic meters of water. This can be reduced by recycling from one fracturing job to the next. The next step is pilot testing, where several horizontal wells are drilled from a single drill site to test commercial viability. This operation would be more intensive than exploration activity. The well pad will be bigger to accommodate more equipment, including a pond, to store the water required for fracturing. Horizontal wells provide far more exposure to the gas-bearing formation and are approximately 2 kilometers in length. When a horizontal well has been drilled, production casing is inserted into the end section of the well bore. Cement is then pumped down the entire length of the casing and back up around the outside to create a permanent seal. Around 16 horizontal wells could be drilled from one pad to minimize the operational footprint on the land. If we find natural gas in sufficient quantities for full-scale development, drilling operations would continue for several months at each location. Once natural gas is flowing from the wells, all drilling and fracturing equipment will be removed from the well pad. The site will be restored and replanted with access for crews to perform periodic monitoring and maintenance. All that would remain visible above ground would be valves, flow lines, and storage tanks. At Chevron, we are focused on identifying and developing our assets safely, efficiently, and reliably. We are committed to utilizing technology to develop new energy resources while reducing our environmental footprint.